Hello, and welcome to our fourth instructional video on how to plan UAS flight operations. This series of videos is brought to you by AmericaView in partnership with the College of Natural Resources and Environment at Virginia Tech, the Virginia Cooperative Extension, and GeoTed UAS. My name is Daniel Cross, and I will continue to be your guide. In this video, we will be creating a simple automated mapping plan with a rotary wing UAS. We will create a mission to map the same area that we did in our last video, so that we can compare the differences between fixed-wing and rotary-wing aircraft. As we have discussed previously, there are a number of flight planning software suites that you can use that will be specific to the UAV and area you want to fly. For this example, we will use the free version of Drone Deploy, which is an app that is used to create automated mapping missions for DJI UAVs. To start with, in Drone Deploy, we don't set the home waypoint. The UAV will set its own home waypoint when it's first turned on and gets a genus fix. Just like before, we're going to draw a polygon around our mission area. We'll start with a square, and we'll drag these vertices to the edges of the field. By clicking these plus symbols, we can add more vertices until the field is outlined. As we create the mission, you can see the app is generating a lawnmower pattern. This is the intended flight path of the UAV. With the basic edition, we only have a few options to play with. The first is our mission altitude. Unlike the software we used with the fixed-wing UAS, in Drone Deploy, we set the altitude and the software then tells us what resolution to expect based on the UAV that we're using. Drone Deploy also has a feature that they call terrain awareness. This uses a digital elevation model to map the flight plan to the contours of the terrain. To enable it, we click this icon here. This will bring up a graph showing the altitude of our flight plan in green and the elevation model in black. To enable this feature, we want to turn on terrain awareness. Now you can see the graph of our elevation has changed to more closely follow the terrain model. The next option is Enhanced 3D. This is a setting for creating better 3D models of objects such as individual buildings. If we keep it turned on, it will cause the UAV to fly the perimeter of the polygon with the camera facing inward and pointing down at a 35-degree angle. For mapping these fields, we're going to turn this off, and doing so saves us about 6 minutes. Now let's go over to the Advanced tab. Here we can change the overlap. By default, it's set to 75% front to back and 65% side to side. If I want to change that, I will first turn off the automatic settings. Remember that increasing the side to side overlap will increase the distance flown, and increasing the front to back overlap will slow down the flight speed of the UAV. If we change both overlaps to 85%, a good setting for mapping forest, it will increase the flight time significantly. However, for a field like this, the default settings are just fine. We can also change the flight direction, and we'll want to play with that to get the shortest flight time possible. Since rotary wing UAVs are able to stop and turn in place, we don't need to worry about overshooting the mission area. And wind is not as much of an issue, since the quadcopter simply needs to tilt into the wind to correct for it. Although winds will cause the UAV to use its battery at a greater rate. Just like with the fixed-wing UAS, we want to make sure the UAV starts its mission at the far end of the mission area. This way the UAV will be making its way back to our landing site. If we run into any trouble, such as a strong wind or a battery malfunction, the UAV is already working its way closer to landing. By doing this, we reduce the risk of a low battery-related accident. We can also set the flight speed. Now in Drone Deploy, this is a maximum speed. So if our front-to-back overlap requires a slower speed, the app will automatically correct and slow the UAV to ensure a good overlap. So I don't normally feel the need to change this setting. However, a slower speed will reduce motion blur in the images. If you're having trouble with rolling shutter or distorted images, try reducing the speed limit. We can also set obstacle avoidance if the UAV is capable, turn on the low light setting if we're flying in darker conditions, and lastly, we want to tell the app what UAV we're using. It should detect this on its own if the UAV is connected. But for this example, I'm making this plan in my office without the UAV, so I'm going to tell it to use a Phantom 4. Now that I'm happy with my flight plan, I want to exit the Advanced tab and give everything a good looking over. I don't see anything that seems unsafe on the map, so I'm going to go check the mission specs. It looks like this mission will take at least 2 batteries, and I need to make a note about that. Drone deploy will bring the UAV back once the battery gets too low, which is around 25 to 20%. However, in my experience, this is too low. Lithium polymer batteries can slowly be damaged if they discharge below 30%. So I know I need to keep my eye on the battery levels during this flight so I can manually trigger the return to home function around 40%. As long as I don't close the app, it will keep track of where I was when I interrupted the mission, and it will return to that spot to continue the mission after I've swapped in a fresh battery. Now that I'm satisfied that this mission is safe to fly and will achieve my goals, I can save it. Since I'm recording this video on a PC, there's one last feature I'll need to do on a mobile device that I'll use to fly the mission. I need to save the background image so that I can use it in the field. Please join us in our next video, where we'll take a look at some advanced flight plans for both fixed-wing and rotary-wing UAS. We'll take a look at how to map linear features, how to shoot video, and how to create 3D models. Fly safe.